Hello class, these are our notes that we're going to make. We're using a little book this time, so we did directions on how to make this book in class, and for chapter 9 we're looking at surface area and volume. I really should have written down surface area first. That's what we're doing first in this unit. Our first couple sections are going to be surface area, then we're going to switch to looking at volume. I also put my name on this, so if something happens to the book we can find it later. I'll try to find you some stickers that we could use to decorate it in class. So we're going to start out by looking at a rectangular prism. So at the top, I want to write this section that we're on, that's 9.2, and I want to write down rectangular prism. And then we have some prisms that we are going to work to cut out in class. And we're really just cutting out what's called the net. So the net is something that I could fold up to make the prism. And we're going to have this flat on our paper, but then we can kind of fold it up and we can see how it would make a prism. So that we can continue to fold it up, we're only going to glue it on one side. So I'm going to glue it on this side right here. I have a brand new glue stick, so we'll see if I can get it open. And then for my first page, I am going to do surface area. So I want to make sure to write down that we are finding our surface area. Surface area. So surface area is going to be basically the area of all of these rectangles that would make up this prism. So we've got some different size rectangles. So I have this rectangle up here, I'm going to call rectangle A, that matches down here. So both of these are going to be the same. I've got my really big rectangle that I'm using as a base. I'm going to call that one B. And I have another one down here. And then I have the rectangle that I've got kind of on both of the sides that I'm going to call C. So we have three different rectangles. So my area that my rectangle that I've labeled B, I'm going to say that this is my, let's say this is my length right here. So L for length, that's a cursive L. And then this is my width. So that's going to be a cursive W. Cursive W's kind of just look the same. And then when I fold this up, I want to think about how when I'm folding in C, this vertical amount right here is going to be my height. So that's going to be a cursive H. So I've got length, width, and height. So when I am finding my surface area, and I'm going to kind of fold this up a little bit, my surface area is going to be 2 times rectangle A, because there's 2 of those rectangles, plus 2 of rectangle B, plus 2 of rectangle C. So my rectangle A, let's see, is made up of a length, and it matches up on the side. This is H, so I have L and I have H. So this one's going to be 2LH plus, when I look at B, I have L and W. So 2LW. So remember, we're just multiplying those two measurements that make that right angle. Like L and W come together at the corner and they're perpendicular. That's why I'm multiplying those to get the area of B. And then for rectangle C, I have my width here and I have my height, so it's WH. So plus 2WH. That's going to be my formula. So if let's say I'm going to go ahead and use a ruler, we'll be measuring in class. I don't have one handy. Oh, maybe I do. Maybe this is a ruler. It's not centimeters. I don't believe I have a ruler right now at home. So let's just pretend, and I'm going to say, these are the numbers I used last year. I don't think they're accurate, though. I think I have a different size rectangle. Let's pretend that our length is 8 centimeters. Let's pretend our width is 5 centimeters. And let's pretend our height is 2 centimeters. So then to find my surface area, I would have 2 times 8 times 2 plus 2 times LW. L is 8, W is 5, so 2 times 8 times 5 plus 2 times WH is 5 times 2. And then we just go through and multiply it out. This one's 2 times 16. The next one is 2 times 40. The last one is 2 times 10. So we'd get 32. And let's see, 80 and 20. So that's going to be 132. And we measured with centimeters, so we're going to say centimeters squared. So that's surface area. So basically we're looking at all the little rectangles it takes to make this. We're thinking about how it folds up and how that goes together, how our opposite rectangles are the same. So we're going to find the area of these two. So we're just finding the area of one and doubling it. B is the same. We're finding the area of doubling that one. And the same thing for A. So it really helps when you're finding a rectangular prism to kind of think about like unfolding that and what that would look like and laying it out flat, because that's really what we're finding. We're finding the area of all these rectangles, if we just flattened it all out, that would make up that prism. So we're going to skip a page because next is going to be volume. So I'm not going to put anything here. And then I'm going to turn my page. And then the next thing I'm going to do is I'm going to look at the surface area of a cube. And this is still 9-2. So 9-2 is going to be cube, and we're going to do surface area again. And when I look at surface area, I'm going to take a cube and glue this down. Remember, I'm only like gluing in the one spot, so I could fold up and see how the cube forms. So let's go ahead and test this out. So remember, a cube is like a special rectangular prism where all of the sides are squares. And I'm just showing you how mine would fold. So this is one of the nets that you could use to make a cube. There's a lot of different nets. It's something that we're going to explore in class. So I can make a cube. So I have down that so I'm going to call all of these a side. Right, this is my side here, which is the same as this side over here, which is the same as my height. So if I'm thinking about surface area, I've got a bunch of squares that are all the same. So to find my surface area, I would take and I would multiply 6 times the area of one side, which is a square, which is s squared. So it's going to be 6s squared. So for our surface area here, we're going to say that S is 3 centimeters. And so our surface area is going to be 6 times 3 squared. Remember, we have to square before we multiply. So 6 times 9, which is 54. And this was centimeters squared. So because we're looking at area, we're still getting centimeters squared. So we're going to skip the next page. We're going to do volume and some other stuff with nets. So I'm not going to put anything there, and I'm going to turn my page again. And we are still in section 9-2. There's a lot of shapes today. And now we're going to look at a triangular prism. And again, we're going to start out with surface area. All right, surface area. So same thing with my triangular prism. I want to glue this down so that I could fold everything up. And really, for a triangular prism, we think about the triangle as being those bases, right? So really, it's almost like this should be standing on its side with the triangle on the top and bottom. But that's just not really feasible for what we're trying to do here. So we're going to glue it on one side again so we could fold it up. And then we're going to figure out its surface area. And this one's a lot trickier because we've got some triangles involved. All right, here's our shape. So on this one, it's really different. We have different rectangles. I have this A rectangle that doesn't match up with any other rectangle. It could. We could have a special kind of triangle with some equal sides, but it doesn't have to. And then I have this B rectangle that doesn't match up with any other rectangles. And then I have this C rectangle, which doesn't match up with any more. So all of these, when I go through and measure, well, we will get to that in a minute. The next thing I have to worry about is my triangles. And I think we can agree that the triangles, there is a match, right? I have these triangles on both ends that match up. And so I think I'm going to call those D. And I'm just coloring them because they match, and it's kind of fun. So we'll call these D. And then we want to think about what numbers do we need to find our area. So to find our surface area, we're going to have our area of rectangle A plus rectangle B plus rectangle C plus my two triangles. So two triangles, which are D in this case. So this is really kind of weird. Probably not the best way to write it. So for A, I need a length and a width. So let's go ahead and using my ruler, I found already that this is a length of 10 and a height of 2. This is in centimeters. So that means when I find the area of A, I'm going to multiply 10 times 2. And then when I go to find B, the length is going to be the same. But this time when I measure the number of centimeters in this direction, I get 4. So remember, our length and our width measurement, so this is my length, this is my width, they're forming at that right angle. They're perpendicular to each other. We're always looking for the two numbers that are perpendicular. So rectangle B is going to be 10 times 4. And then rectangle C is 10 times 3, because my height's going to be 3. So for my last two triangles, I need a base and a height. So I can see that I already have the base. My base is 4, but my height should measure to the top of this triangle, and it should make a right angle with my base. Should be this number right here. And when I measured that, it was pretty close to 2. So I have 2 times the 1/2 times the base times the height. The base is 4. And the height is 2. So it's kind of cool because the 2 times 1/2 is just going to cancel out here. So we're going to get 20 plus 40 plus 30. And over here, the 2 times 1/2 is gone, so all we have is 4 times 2, which is 8. And then when I add up all those areas, 2 and 4 is 6 and 3 is 9, so 98. And this is centimeters squared again. We're going to leave another blank page for volume, for a triangular prism volume, and we're going to do our last shape of the day, which is a cylinder. And the cylinder is kind of the tricky one. So we're still in section 9.2. This time we are looking at a cylinder. And the cylinder is going to be surface area first. And this one's a little bit trickier to glue down. So what I'm going to do to glue it is I'm going to kind of glue a strip right here between my two circles. So I'm going to turn this over and just kind of put the glue along this line. And I'm going to glue that down. And then I could see how we can roll this up. And this would be around the middle of my cylinder, and these would be both of my ends. So for my cylinder, what I've got is I've got a giant rectangle and I've got two circles. So let's think about what's going on here. So for my surface area, I have a rectangle plus two circles. And maybe I should write out the word circles because that looks like O's. It looks really weird. Let's write the word two circles. So for my rectangle, my height is just going to be my height. But it's really kind of interesting here because when I roll this up and think about what's going on, and I think about matching this up, this distance from here to here along the top of that rectangle matches with the distance all the way around that circle. So when I think about my rectangle being a base times my height, my entire base on this is really like my circumference. This is my circumference. And my circumference is pi times the diameter. Or if I wanted to do everything in terms of radius, remember my diameter is 2 times my radius. So I could write that that's 2 pi r. So I have 2 pi r in this direction, and I have a height of h. I also want to put an r inside my circle, the top circle and the bottom circle. So I'm going to go ahead and move this up now. So my rectangle is base times height. My circles are 2 pi r squared because there's 2 of them. Pi r squared would be 1. But then I want to remember that the base is really 2 pi r. So I end up with 2 pi r times h plus 2 pi r squared. This is really different. So when I measured with a ruler on this one, I found that my height was about 4 centimeters. And I found that my radius was about 2 centimeters on this. So let me go ahead and plug in those numbers. So to find my surface area here, and so like this is kind of like a formula, but we're going to go through and we're going to use it. So to find my surface area, I need to have 2 times pi times my radius, which is 2, times my height, which is 4, plus 2 pi times my radius, which is 2, squared. So let's see. This is going to be 2 pi times 2 times 4. So let's multiply all of our constants. 2 times 4 is 8, times another 2 is 16. So we have a 16 pi, plus 2 squared is 4. 4 times 2 is 8 pi. So I can add these together because they both have the pi symbol in them. So 16 plus 18 is 24 pi, and that's going to be centimeters squared. That's my with pi answer. So I could certainly go through and I could remember that pi is equal to about 3.14. And I'm actually going to use a pi symbol on my calculator, which is a little more accurate. And I could say, hey, this is approximately equal to 75.4 centimeters squared. I had 0.39, so I rounded it up to 0.4, and that will work as well. So we're leaving this page blank right here. We'll do volume of a cylinder later on. Just to review, we came up with a surface area of a rectangular prism, and we have kind of a formula for that right here. We have a cube, and we came up with the formula for a cube right here for our surface area. It was a little bit tricky when we looked at this surface area because of the stuff with the triangles. And the triangles can be a little bit weird. So we didn't really write out a formula. We just kind of thought through how you're doing the area of 3 different rectangles and the area of 2 triangles. This is going to be the tricky one. This is the one that you're going to need help with. And then we do have a formula for cylinder. We went ahead and boxed that in as well, but this is a more difficult one to use. So the numbers on this are a little bit trickier as well. So hopefully this will help you to work out your first worksheet on your first worksheet on surface area. We've got all different kinds of shapes on there. And we're just going to continue on this book for the entire chapter. So as always, if you need help, please make sure you ask.